So hello, welcome back. I'm Bradley.
I'm Joe.
And together we are siblings in science. Because Joe cut me off next time, our Twitter handle is siblings, at siblings in sci. Please follow us and tell us what you think.
He's good at marketing, isn't he?
Thank you.
Yeah.
I hope I've got that Twitter handle right now.
Yeah, it's probably not.
It is.
We'll link to it.
Disclaimer.
Yeah.
So last time Joe was telling us about time dilation, and next of all he was going to tell us about length contraction.
Or Lorentz contraction.
But because we ran out of time last time, I've kind of designated 5 minutes for Joe to talk about length contraction.
We should probably mention the last video we think was slightly too long.
Yeah.
So we're going to cut this down to 5 minutes. We're already a minute through, so we should probably get started.
Yeah. So do you want to really quickly summarise what?
No, because I have 4 minutes left.
Okay.
Let's
go length.
If you want to summarise what time dilation was, look on Wikipedia.
Or see our
last video. That would be a better plug, wouldn't it?
Yeah.
Okay.
Okay. You have 5 minutes starting from. 5 minutes.
4 minutes. We're making the video 4 minutes.
5 minutes.
We'll start arguing now. We'll stop in at 5 minutes. No.
Okay. Go.
Okay. So you know that I will summarise time dilation because actually last time we looked at how if you have a light bulb, you would measure if you were moving quickly, you would measure the flashes of the light bulb slower than you would if you were stationary with respect to the light bulb.
Yeah.
Can you understand that?
Yeah.
Great. Okay, so what length contraction is basically the same effect as time dilation, but with lengths. So, it means if you have a box, and you have the box stationary, and let's say the box is exactly 1 meter.
Problems with the sun.
Yeah.
We can't control it just yet.
Okay, so imagine the box is 1 meter, and again, we're the UK, so we're using, I'm using scientific units. 1 meter, and that's if the box is stationary. Now imagine you are running past the box. How long do you think it's going to be measured? Now I'll give you a clue here. So time dilation, when you ran past it, the time got slower.
Yeah.
So this is called length contraction. So what do you think happens to the box?
It gets smaller?
Exactly, yes. So the box gets smaller because it's called length contraction.
If you saw his hands, they kind of went slightly in, so it gave me a bit of a clue.
Wow. Okay, so if you're moving past the box, moving really quickly, and when I say really quickly, I mean like 0.9 times the speed of light.
Okay, quick, just run really quickly.
Oh, what?
Yeah. I can't see him. There he is. Okay.
Okay, that was running quickly. But so if you do that, really faster than that, like 0.9 times the speed of light, we're upside down.
We're upside down. There we go.
0.9 times the speed of light.
We're not cutting.
No, okay.
Yeah.
0.9 times the speed of light, then things get smaller. 0.9, I say 0.9, I just mean like if you were running relative. So the reason we don't see this in our normal daily lives, why do you think we don't see this in our normal daily lives?
Because we're not usually running around boxes or measuring it that way because we're seeing it through, or is it because we're seeing it, or
so what's the difference?
Or is it because it's happening all around us?
No, okay. So what's the reason is what's different between our speeds and the speed of light? So what's the speed? What do you think when you think of the speed of light? Do you think of something really quick or really slow?
So really quick.
Exactly. So the speed of light is incredibly quick.
So it's bound by different kind of laws of
not
really the way you see it.
Yes. So what happens is the faster you're moving. Now that we have time dilation, the faster you're moving, the closer to the speed of light, the greater these effects become.
Okay.
At low speeds, so like the speeds that we as humans deal with, like 10 miles an hour, 30 miles an hour, they are nowhere near fast enough for us to see. The effects happen, but they are minuscule. It's like I don't know. It's probably far smaller than the length
we
of an
can't
atom.
comprehend what's happening.
No.
As in physicists obviously can, but when we see it around us, we can't comprehend.
Yeah.
So in this and last time, we had a light bulb moment with time dilation, and then length contraction as well. So thanks for watching. We've been Siblings in Science at Siblings in Sci. That is 5 minutes 2 seconds.